Hello, I'm Jonel Cordero. Danny is out this week with Telegram FUD. Danny, the team wishes you a speedy recovery. In chicken news, Fernando Mercado joined Popeye's head of marketing earlier this year. When asked about plans to market the new chicken sandwich, he stated, "When we start, everyone will know." This just in, Facebook's Libra project launched their new bounty program well ahead of their anticipated launch. When asked about blockchain data security, they responded, "Wait, it's supposed to be secure?" Just 12 days until Funface deletes its Twitter account. In Dragonchain news, Dragonchain's new marketing strategy has taken everyone by surprise, including me. Chad just doesn't get anti-hype marketing. President Trump this week leveled new attacks against the Federal Reserve, marking that our Federal Reserve cannot mentally keep up with the competition, and has been calling it wrong for too long. Urging the Fed to slash interest rates to avoid a recession, calling for it in the media, the president tweeted, "Look at Tether, we need currency management like these guys." The president sent many of his advisors out anonymously to Telegram and crypto Twitter to broadcast the official message, "Is dollar dead? Is this USD token worthless?" Well, that's it for Dragonchain News. Until the next time they need me to market again.
Hi, I'm John, and I am working with the Dragonchain team to give you a course or tutorial series on how to launch your first unmanaged level 2 Dragonchain node. So let's take a look at a very quick sample video of the process that you'll learn in depth, step by step, in the course. Take a look. Okay, so while you're enjoying the sultry tones of stock elevator music number 3, you can obviously see that I've sped this up. We're looking at the process that takes 28 minutes in the real-time course. We're going to look at that in 1 minute. But I'm demonstrating every single click and command that you're going to type in to install your own unmanaged level 2 Dragonchain node. It's really not as hard as it seems like it is. You do need to have some basic Linux administration skills, but those can actually be picked up pretty quickly, and you can create a Linux VPS pretty quickly. So, like I said, we're just taking a look here. I really go through and demonstrate absolutely every step. Now, obviously in the course, I've broken it out into more detail, and obviously we take our time. And again, you're going to have documents that give you a list of every single command with an explanation in order that you're going to put in to go from a basic Linux system to an installed and running and operational Dragonchain node. All right, and there you have it. Thanks for watching.
Hello and welcome. I'm Danny Ludke. We're here to show you Dragonchain Eternal and how a transaction is verified using DragonNet. Dragonchain started off with this simple idea. The idea that you should be able to integrate blockchain in a simple, secure, and fast way, in a way that's developer-friendly, that you can deploy anywhere or in any cloud. Transparency is key to connecting with our customers to build trust and loyalty. And we're going to show you how Dragonchain can verify transactions for transparency using DragonNet as a service. There's no infrastructure to set up. There's no time-consuming consortiums or partnerships that need to be arranged. It's just ready to go. By storing data on Eternal, we can make the transaction public, immutable, and tamper-proof. Let's take a look at Eternal. You can enter a URL to save a website or enter your own text snippet. If you enter a URL to a Twitter post, it'll parse the URL as a special type of transaction type called a tweet. Let's go ahead and do that. We'll go ahead and enter a tweet and post it to our blockchain. Now, as this transaction goes through the Eternal chain, you'll be able to see the transaction and the verifications as it goes through the 5 layers of DragonNet. Now that we have the transaction, we can go ahead and use the transaction ID to get a proof report. I can see a summary of the transaction itself. I can see the transaction ID. I can see the transaction type, along with the timestamp and the hash of the transaction. We can also see the raw data of the transaction before it's recorded to the Dragonchain. Let's go ahead and take a look at the raw data. We can see information regarding the header. We can see the payload, including information regarding the proof itself. We can see the raw data on the L1 blockchain if we go ahead and take a look at the raw data. Additionally, we can see information regarding the header. We can see the stripped payload, and then we can see the proof of the block that it resides within. The L2 nodes check the validity for blocks and the individual transactions, which can be done in confidentiality without exposing the actual data. Now in this case, the L2 validations have not occurred, and so let's go ahead and refresh. And as we take a look at this transaction, we should be able to see additional layers of the transaction get verified as time passes by. Now, in this case, what we have is 3 different L2 blocks that have been verified, and you can see that none of the payload data is transferred up to the L2s. It's just the verification that the transaction had occurred on the L1. And in this case, what we'll go ahead and do is take a look at the level 3 blocks. And the level 3 blocks verify whether there's enough diversity between the layer 2 nodes. And as we take a look at this, we can see that there were the 3 validations that occurred. And at the L4, the L4s provide a notary and a timestamp intercord proof to ensure that the original transaction is gone unchanged. So when we take a look at the raw data, we can see the L4 data along with the proof itself that was provided. As time goes by, the L5s will validate and act as a public bridge to blockchains such as Ethereum, Ethereum Classic, or Bitcoin. This allows the business to transparently demonstrate in a public, decentralized way that the transaction took place without exposing the details of the transaction. Let's go ahead and take a look at a completed Eternal transaction. So this is a transaction that I posted a while ago. This was Elon Musk who just tweeted out Ethereum. And I can take a look at things like the cumulative hash power equals 613 million exahashes of transaction hash power. And I can actually see here in this case that the transaction took place and that it took place on the Bitcoin network itself. By using Interchain, we're able to record the transaction and it gains cumulative hash power. This combines the hash power of all the interchains into the strength of the chain by creating a blockchain of blockchains. If you want to go to eternal.dragonchain.com, you can check it out, kick the tires, and give us feedback. Thank you so much for watching.
All right, hey, Danny, the camera's right here. All right. Okay. So, this week we want to talk about Postgres. So, there's some really good stuff in there this week and the Academy course we do think is going to go out next week for the launching your own level 2 verification nodes, which it's pretty cool. I think at least 3 or 4 people are running stuff live out there right now. So,
nice.
Yeah,
nice.
Pretty neat. So,
awesome. What else is new?
Jeez. I don't know if we'll have time today. I want to talk about, maybe it'll be next show, but I do want to talk about the potential federation of DragonNet and an extra pool of rewards for unmanaged nodes. Because we really want to try to get people to run them on the outside just to decentralize more. You know, we have a good number of nodes running inside now. So
excellent.
Yeah.
One of the things that we were talking about this week was Postgres and what is Postgres and what does that have to do with blockchain. So why don't we talk a little bit about what are our plans with Postgres and what is Postgres?
Okay. On the what is it's a enterprise relational database, open source. I think it's the best relational database. I've used it for a long time, and I used to be pretty well into it. I haven't had to build anything with it for quite a while myself, but I'm a big fan. It was always the fastest, the most compliant SQL standard database, and it had a lot of amazing features, geospatial, all types of really cool stuff. So, as to how we're looking at it and why we're even, why are we talking about it? We use it a lot internally, of course, but we're looking to integrate, and it's almost like an interchain where we're connecting blockchain to traditional products and services, and this would be one of them that would be really powerful because on the one hand, and we don't know absolutely where we're going to hit yet first, but we're just starting to look at it. But on triggers, I mean, just the simple fact that just like an interchain between Dragonchain and Ethereum, that we have a watcher and a publisher contract, right? And so those would be directly applied on the trigger side, so that an event on your Dragonchain node could cause an entry or a change or something to happen in your database, your more traditional relational database, and on the other side, a change in your database could trigger a call out, whether it's just to ledger a transaction or to actually throw out something that ends up on Ethereum, doing some operation in a smart contract.
Interesting. So if you did do an integration like that, would it what's the difference between relationship databases and blockchain or a Dragonchain? And what type of data would you store on both, and what's the use case for it?
And this is a pretty deep subject, right? We take a lot of discussion, but basically, the relational or the old time traditional good solid enterprise databases where you have immediate consistency. That is, once you write something, it's there. So if somebody else queries that same table, the data's there. Versus non-relational, maybe more modern database where they're built for scaling and built for multi-threaded applications where you're splitting data across thousands of nodes and doing some operation, where that has eventual consistency. That is, when you write something in there, someone else might read it and it might not be there yet, but it will eventually. So you have to treat them different ways. And the weird thing about it is, I kind of, some people consider blockchain to be somewhat, it is eventually consistent, depending upon what blockchain you're talking about, because I might write something that you might not see yet.
So you're talking about the differences between immediate consistency and eventual consistency, right? So let's land on that first and help you. Okay, so what's immediate consistency?
That's when I write something to a table, and anyone else with access to that table will see that result as soon as the transaction is completed. Right?
Okay.
Whereas eventual would be, I write it, and it might be on some node over here. You might be operating on some node over there. Sooner or later, all of the nodes will be in sync, right?
Now it sounds like I'd want the first one, right? Immediate consistency. Now, why would I want to deploy something built off the second one with eventual consistency?
Usually for scaling reasons, like if you're Google, if you're crawling web pages and needing to do operations to do whatever they do to score them, whether it's number of words, the old algorithm where it's just counting words, right? That trying to put a lock on a row in a single database isn't scalable enough to hit the tens of millions or billions of pages that they have to do that with every day. And it depends on what you're doing, but anything like that, Facebook or LinkedIn or other social networks where you have millions of people hitting data at the same time and you have to build feeds for them, the same type of thing.
And you can do types of risk assessments and stuff on the data prior to writing it too? Is that something else that can take place?
That's something that you can apply, and it's interesting too because from pretty early days with Dragonchain, and I don't talk about it too much because it's usually a very small audience that cares about this, but I kind of consider Dragonchain to be a spectrum of consistency, and we call it spectrum of trust usually, but it's also on the other side that if I own a business node, I can have immediate consistency because it is effectively centralized. I can decentralize it, but as soon as data's there, I have it, right? And yet, if you are getting a feed of my data, you could accept it as soon as I write a level 1 business node block, right? You could say, okay, that's good enough for me, right? You could also, though, decide to say, let me wait until we have enterprise governance at level 3, or let me wait until there's a notary at level 4 that somebody that I trust on the outside says, yes, this really happened. Or if it's a extremely valuable or sensitive transaction, you could say, I'm going to wait until at least a few $1 billion worth of hash power is applied on Bitcoin, Ethereum Classic, and then you can say, now I will accept this as good data, right? So it's weird. We have kind of a mix on this side, but we're trying to hit because we've seen a lot of applications where we needed something that had a little more horsepower for queries, typical things you build in an app. So
Interesting.
yeah.
So as you start to look at the tie between Dragonchain and Postgres, would that just be would it be a DBA? Would we just be able to work within Postgres and connect in to Dragonchain commands, like write Dragonchain or?
Yeah. I mean, I think the simplest form is the triggers that I mentioned at the beginning there. There are a couple of other things that would be a little more complex, but could be interesting because typical data model data design stuff, I guess, would be that if I have a lot of complex data with complex relationships in my old relational database from the 90s, right? You would have a lot of that going on. You would want to put as much of the logic as possible, or at least a lot of the logic specifically dealing with arranging the data in the database in a stored procedure where the code is running right on top of the database, where it's tuned very effectively for what data is there and how it's modeled. And what we're wanting to do is, and Postgres is pretty amazing in this, that they have multiple languages. They have the simplest all the way up to, I know they have Perl. I can't remember what other languages they have, but it's kind of crazy because you can write more advanced logic in the database working directly with and on top of the data. And we want really to tie that into blockchain, because then we can effectively say, just like how level 1, because we have a hybrid architecture, so that level 1 node can run any language. We've demonstrated shell scripts, we've demonstrated, of course, Node, and there's some Go smart contracts out there. And we support Java and C# and whatever else, right? Mm-hmm. But you imagine if we said the same things, that you write a stored procedure in Postgres, whatever language supported in Postgres, doesn't matter to us, and we store that so it's provably the same, and we'll have to figure out a couple of things on how we want to do it effectively, but that stored procedure would act as a smart contract inside the database. So it'd be connected to your level 1, but it would be, and managed by your level 1, but it would be operating inside of your traditional database.
So what's the advantage of having a Sprock and a smart contract?
It depends on where your data is, right? And that's when we integrate with more traditional systems, legacy systems especially, this is a pretty amazing capability, because a lot of these things will already be written, right? And they might just need some ledgering, or they might need a further interchain where it might, connect to Dragonchain and then also operate something on one of the other supported interchains.
Interesting.
Yeah.
Do you think this is going to help adoption? Because one of the things I see is there's hardly any enterprises out there with blockchain engineers or blockchain administrators, right? And so there's not really a person to operate the blockchain within businesses. So do you think this is going to help with like the adoption and those things?
I would hope so. And it might be I don't know how you say it, like it's somewhat of a of a stretch at first, because just like sysadmins can now use Dragonchain with, it's like you don't have to be a pure coder if you're a script writer that does glue code on, pulling systems together. You can write that into a smart contract. I mean, much the same way a DBA or some other data architect could start building smart contracts inside of their deep inside of their databases. So you think about with big data applications, you think about with any legacy systems. It's pretty important, pretty amazing, right? So
Excellent. Well, anything else about Postgres before we move on?
More to come. We think it might be one of the strategic bounties that we put out there. For people to build stuff.
Why don't you explain what the bounties are?
Okay, so yeah, we're gonna have a page and
Wait. So step back. What's is a program? Is it a what is this? Is it a website?
Yeah, it is a organizational program, right? There will be a website that has a list of projects categorized. Some of them will be featured, where a lot of them will be either us or customers, things that aren't top of priority, where we don't have our people working on it right now, but it's a way to scale it, where we need this built, and it's going to take us a few months to get to it, so why not put a bounty on it and see if someone else wants to build it earlier, right? And start building in, and we already have some people on the outside that are wanting to do this, and it's also a good chance for us to figure out who we might want to bring in and hire, right? So it's pretty neat stuff. And so we'll have that list there. There will be different scores, there will be criteria for acceptance. Some of them will be more competitive, where the first one will get more money, the second one will get a little less, but we'll still pay it. And there will be some of them too that are really simple, and some of them that will become products, I think.
So is this all built on open source, or how
Yes.
is the code going to happen?
Yeah, I think across the board, I'm pretty sure every one of them will be required to be open source. So anybody who writes it will have to agree, yes, so we'll release this, and I don't know whether we do Apache or MIT or something, but we'll say you have to release it as open source. And I think there will be tiers too. You build it, you get something, you have proper unit tests, other testing in it, you'll get something, you get documentation, you'll get something more, you write a blog post describing it, or build out some examples, you'll get more. So we're going to build it up so that it's, because some people can't write. It's like, oh, I can write the code, but I can't write a blog, so we don't want to require that, but we'll give bonus.
Oh, no.
Or maybe you get a team, right? Maybe it's like, look, I'll write this, you write the blog,
We'll submit together.
Yeah. So hopefully
Nice.
it works out like that.
Cool. Well,
So, signing off. Next week, more on the verification nodes. There's a lot of stuff going on. Oh, PAX event stuff. We'll have recordings from the panel and or other things from the gaming event in Seattle this week. So it'll be good.
fantastic.
Goodbye.
It's crazy, JoJo's craziest merch sale ever! Get everything in Dragonchain merch! Get it on out during Crazy JoJo's craziest merch sale ever! JoJo's prices are insane! We are not undersold, we will not be undersold, we cannot be undersold, and we mean it! Get a JoJo shirt, get a Dragonchain sticker, get a hardware wallet, and get a limited edition JoJo while you still can! Go to merch.dragonchain.com. That's merch.dragonchain.com. Merch.dragonchain.com.